As of now, we discussed about the decoder circuits, and we try to develop the higher order decoder circuit with the help of lower order decoder circuits. The second kind of the data processing circuit is the encoder circuit. Encoder is the opposite of the decoder. Like, see, in the decoder we have uh, uh, let us assume if I have n number of input in the decoder, so the 2 to the power n number of outputs we can have. Okay, so in the decoder, if I'm talking about the encoder, the operation will be opposite. Like 2 to the power n number of input will be there, and for that we will have a n number of outputs. Okay, so this the simple circuit could be like, if I am considering 4 to 2 decoders, so the total number of inputs will be 4, and the total number of outputs that we can get it out of this circuit will be the 4 number of outputs. Okay, so how it can be designed and what procedure I need to follow. Okay, so let us try to see how this circuit will work. As we know that I have a 4 number of inputs. Okay, and if I have a 4 number of inputs, then how it can be affected. Okay, so let us assume the first possibility is, if the first case is if I0 is equal to 1 and rest all other are 0. So if this is the case, then the output I will get is 0, 0. 0, 0 will be the output if I1 is high. If I2 is equal to high and rest all other are 0, then the output will be 0, 1. If I made one mistake. This should be I1. This should be I1. Okay, so if I1 is high, then output should be 0, 0, 1. Third case is like, if the I2 is equal to high and rest 3 bits are 0, in that case the output should be 1, 0, and in the last case I should get 1, 1. Okay, and one more table I have given over here. If there are some enable signal, okay, if there is some enable, let us assume it is the active, let me consider active low, active high only. If there is some enable signal, in that case, if it is not activated, like if E is equal to 0, so if I have active high and E is equal to 0, so whatever the conditions we have at the input, output will be that will be 0, 0 only. Okay, so if it is not enabled, then I will get 0, 0 output only. So this is the based on enable signal. Okay, so if it is active high, then this must give the outputs yes, this is what I said. Like Jayant is asking, like in the previous slide, if we are using active high enable, then we will remove the not get too. Yes, yes, of course I have to remove it. I just told you, because we are taking two times complement. So complement of complement, that will be true value. So we can remove both. Okay, so here if enable is equal to 0, in that case the output will be 0, 0 only. Okay, now let us try to see how we can design these things. Okay, so to design these things, we can have, like, see here we have a 4 number of inputs: I0, I1, I2 and I3. Okay, so these are the number of inputs. Now what we need, if all are 0, then the output should be 0. Okay, if I1 is equal to 1, then the B0 should be 1. Okay, so the B0 should be 1 and something like this. So B0, so now what I need to see, B0 is equal to 1 if and that depends on two things. B0 depends on, yeah, so let me take this table. This is 1 and this is 1. In two cases, the first case when let me change the color first, then it will be better. If you see here, if I'm talking about the B0, in the B0 I'm getting high for 2 times, and for the first high, I am getting I1 should be high, and the second case I3 should be high. Okay, so if I am ORing I1 or I3, then I will get the B naught. Okay, so if any one of these is high, I will get B naught should be high. Okay, and in the second case, like if I want to make B1, so I can see here B1 is high if, yes, so B1 is high in two cases. One case is this one, second case is this one. And if we see, the cases are the I2 and I3. Okay, I2 and I3 that are responsible. So this B1, we can design something like this. By ORing I2 and I3, we can make the B1 as an output. Okay, so this is the simplest circuit that we can design with the help of logical gate. And this circuit is nothing but this is the encoder circuit. If I want to write some expression for this one, so if you see the B0 is nothing but B0 is ORing of I1 and I3. So I1 plus I3 is the B0, and B1 is nothing but this is ORing of I2 and I3. Okay, so this is the simple expression. But yes, of course, the condition is if E is equal to 1. Okay, so this is how we can get it. So
Hello,
yes,
sir.
yes, please.
सर इसमें आई नोड का क्या रोल है?
I naught does not roll on the logical output. Okay, so I naught is just an input. Like if I know, even though I naught is equal to 1, because we know that it will be same, like this case is same like the last one, whether I have not enabled or I naught is equal to 1. So that will by default consider the B naught and B1 is equal to 0 only. So B1 B naught will give you the 0 only. Okay, so this is the by default case. So in the two cases, I will get logical low, both the outputs low. Either it is not enabled, or even though if it is enabled and the I0 is equal to 1, then you will get the same output, like logical low output. Okay, doubt is clear?
सर इसको रिमूव नहीं कर सकते?
No, we cannot remove, because the problem is we are considering here 2 to 4 decoder, 4 to 2 encoder. And for this one, we must have 4 number of inputs. And then how you will decide what is the MSB and what is the LSB, and which one is the higher order input and which one is the lower order input? Yes, please wait. I will just tell you later on like how we can utilize these inputs as well for the designing. For the simple encoder, yeah, this is unused. We are not using it. But for the other kind of the I0 may be required to make the circuit. So please wait and I will tell you. Okay.
Sir,
Yeah, please.
sir, in this, if we are giving any other inputs, so that will be 0 or something else, or it will change accordingly.
Yeah, you are saying like as of now we have considered only one input is high and all other inputs are 0, right?
Yes,
and
sir.
if we have the cases like 0 0 1 1, something like that, or any other combination, then what will be the output? This is your question?
Yes, sir.
Okay, wait, next slide is the same. Okay, so the next one is the 4 to 2 line priority encoder. Okay, where will like as of now we see in the previous one only one input is high, but this is not the true in any case. Okay, in that case what I have to see, if more number of inputs are high, then how I will decide what should be the output. So this kind of encoder, we can call it the priority encoder. Okay, so this configuration of encoder is the priority encoder, and let us try to see how priority encoder works. Okay, so again we will have 4 number of inputs. If I am making the 4 to 2 in line priority encoder, 4 number of inputs will be there and the 2 outputs will be there. Okay, and the possibility could be just like what we have already seen. But there will be some different possibility or different configuration. What will be that configuration? Yeah, the first case could be like if it is not enabled. Okay, if E is equal to 0 or not enabled. So whatever the case we have here, output will always be 0. Enable is equal to 0. I am considering the active high kind of, in the case of active high. For active high logic, if E is equal to 0 and whatever the condition of I is, I will get always 0, 0. Okay. Now, what are the other cases, other combinations? The first combination could be the I0 is equal to 1 and rest all other are 0. So in that case, I will get 0, 0. Second combination could be, I just told you, I2 is 1. Okay. But if I see here, if I have a combination like 0, 0, 1, 0 or 1, 1. So these are the two possibilities where this is I2 is the maximum. Sorry, this I1. So this, again, I made mistake. This should be I1. Okay. So the I1 is the maximum number of, like the highest bit, which is at logic high. Okay. Because these two are at logic low. So I will consider I need to give the priority to this I1. If this is 1 and this is 0, and now that we can have the combination like 0, 0, 1, and we can have a 0, 0, 0, 1 and 1, 0, 1, 1. 4 possibilities could be there here. Like it could be 0, 1 and 0, 1 for both. Okay. So there could be like how many combinations we can have? We can have a 4 combination out of it. Okay. So there are possibilities. What I wanted to say, suppose if I1 is high and higher order inputs are not high, so I will consider this is of highest priority. Okay, I1 is at the highest priority. Now if I2 is high, okay, and what is the condition of these two are, it does not matter. I will give priority to the I2 only. Similarly, if I1 is high, then whatever the condition of other bits are, I will not take care. I will give the priority to the I3 only, not to the I2. So this is what we can call the priority encoder. So let us take some conditions and then we will try to solve all these things. Okay, the first condition could be like if the I1 is high, so it does not matter what is the status of I0, I will consider the I1 as a highest priority. So I need to give the priority to the highest number of bit. Okay, and that starts from I0 to I3. Okay, so if this is the case, in that case 0, 1 should be the output. If I2 is 1 and I don't care what is the status, there could be possibility like it could be 0, 0. There could be a possibility like it could be 0, 1. Possibility could be like 1, 0 or 1, 1. So all possibilities are there, like 0, 0, 0, 1, 1, 0 and 1, 1. So in all the cases, all the 4 possibilities, I will get 1, 0. Okay, because here I2 is activated. So the priority should be given to the I2. Similarly, in the last case, if I3 is equal to 1, so whatever the condition of I2, I1 and I0 is there, it does not matter. The output will always be 1, 1. So this is the truth table for this case. Your doubt is clear?
Yes, sir.
Okay. Now let us try to see how we can design this one. Okay. So if you see here, in the priority encoder, what are the different functions that we have here? Okay. So let us try to write those things. The first function that we have here is the B1. B1 is equal to summation of M. Can anyone tell me what are the minterms which are possible for the B0? What are the minterms which are possible for this one? 2 and 3 only? No. Let me tell you one thing, then you can start thinking about this one. If you see this first case, okay, in the first case, if you see, the possibility is 0, 0, 0, 1. Okay, and if you see here in this one, yeah, you just told me like 2 and 3 is possible. But if you see this one and this one, B0 is high for two cases where I can have, okay, sorry, I made for B1. Okay, fine. So let me check all these things. So how it could be done. So let us start with the B1, B0, then I will tell you the B1 again. Okay. If you see here, B0 is high for this case and for this case. And if you see here, the input combinations, like total number of input possibilities could be like 0, 0, 0, 0 to 1, 1, 1, 1. So these are the total number of possibilities are 16 combinations. Now, if you see this case, in this case, B0 will be high for 0, 0, 1 cross. 0, 0, 1 cross means what? 0, 0, 1 cross means possibility could be 0, 0, 1, 0 and 0, 0, 1, 1. So these two are the possible for in the first case, if I'm considering this one. Okay, and now I have to consider the second case. If we consider the second case, I have 1 cross cross cross. So what are those possibilities? The possibilities are 1, 0, 0, 0, 1, 0, 0, 1, and so on. It is up to 1, 1, 1, 1. So the total possibilities I will have, that will start from 1, 0, 0 to 1, 1, 1, 1. So these all are the possibilities here. Let me repeat it again what I'm saying. If I'm talking about the B0, B0 has two logical high. One is this one and the second one is this one. And if I'm considering this first one, in the first one, I have combination 0, 0, 1, 0. 0, 0, 1 cross. 0, 0, 1 cross is here. So I can have two possibilities, 0, 0, 1, 0 and 0, 0, 1, 1. Okay. And 0, 0, 1, 0 is nothing but this is the 2. And 0, 0, 1, 1, this is nothing but this is the 3. Okay. Now I have one more possibilities, which is 1 cross, cross and cross. 1 cross, cross, cross means what? I can have 1, 0, 0, 0, 1, 0, 0, 0, 1, and so on. Okay. So these all are the possible ones. So what are the other ranges? Can anyone tell me? 1, 0, 0 is nothing but that is the 8. And 8 onwards up to 15 is the min term. And 8 to 15 will be the min term. So 8, 9, 10, 11, 12, 13, 14, and 15. So these all are the min term that we can have for the B0. Now, please tell me what are the min terms for the B1. Okay.
4 to 7, then 8 to 15.
4 to 7, then 8 to 15. Let us try to check. Okay, so four to 15. Jayant is saying 4 to 15. Okay. What you said?
The same.
Arpit?
4 to 7, then 8 to 15. Same. 4 to 15.
Same, 4 to 15, right? Okay. 4 to 15. So let us try to check. So yeah, this is correct. So what you said, this is absolutely correct. Because I need to check this one. So here we have a 2 high. So yeah, simply 0, 1, 0, 0. So 0, 1, 0, 0 to simply like both the combination. That will be 1, 1, 1, 1. So this will be the range for this one. So 4 to 15 will be the set. So 4 to 15. I'm directly writing. You can check it out. So once you are ready with this one, Then you need to solve the K-map and you will get the simplified circuit. So let us try to make the K-map for B1. So B1 is like 4 to 15. 4 to 15 will be something like this one. 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, and 1. So all these will be 1. Okay. And similarly for the B1 and B0, we will have 2, 3, 8, 9, 10, 10, 11, 12, 13, 14, and 15. So this will be the set. Now let's try to make the pair. How the pair will look like. For this one, can anyone tell me what are the pairs that are possible in the B1? What pairs are possible in the B1? We can have two quad here, right? One quad I can make this one, and the second quad that I can make is this one. So I can make two quad over here. Okay. And if we try to simplify, what is the logic? And similarly for this one, we can make one octave, not the quad, two octave. So one octave will be here, and one quad I can make something like here. So one quad and one octave will be for B0. And if we try to simplify these two, what will be the output? Let us try to see. Can anyone tell me what is the simplified version of B1?
I2 plus I.
Sorry, what?
I2 plus I3.
I2 plus I3. Okay. So you are saying I2 plus I3 will be I2 plus I3. And what about this B0?
I3 plus.
I3 plus
I1, I2 bar.
I1, I2 bar. Okay, let us try to see. In this one, we have to make the pair with this one. So from here, this I3 will be cancelled out. I2 will get, we will get I2 bar. Okay, I2 bar from here. And from here, this I0 will be cancelled out, and I1 I will get. True. Yeah. So the I2 bar I1 or I1 I2 bar. Okay. Okay, so Jayant asked one question like why we are considering all don't care to be 1. Yeah, so even though you will consider the don't care, right? Even though you will consider don't care in that case, you can make the pair of don't care as well, right? So because the important thing is, see here, yeah, this is a very good question. Okay, what Jayant is asking, why we have replaced this with 1. Okay, we can also make it with the don't care also. So let us try to see if I want to make the don't care, then what will happen. Okay, what will the K map? Let me try to make that one. Okay, suppose this is the K map, and if I'm considering the B0 or the B1, simply B1, if I'm considering B1, so I need to first consider I2 should be 1. Okay, and they don't care. So how you will get the numbers which are the min terms will be high? Number you can get simply by changing the combination of this one only. Okay, otherwise if you will get this cross only, 0, 1 cross will not give you any of the number. Okay, so you have to find all the possible numbers that you can get it. Okay, so that is why you have to put it like combination of cross 1. So 0, 1, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0, and 0, 1, 1, 1. These are the possible combinations that we can make out of this one, 0, 1 cross. If we have the min term like 0, 1 cross, you cannot say what min term this is. Okay, so what it simply means that whatever the combination you will have, like 0, 1, 0, 0, you will get B1 high. 0 1 0 1, you will get B1 high, B1 high. 0 1 1 0, you will get B1 high, and 0 1 1 1, you will get B1 high. So B1 will be high for all these combinations. That is why we have kept 1 here. You got the point, or I need to discuss it again? Okay, so basically what happens, this B1 and B0 is high based on the input combinations. So the K map is made based on the B1 status, not the don't care status in the inputs. K map is always made in terms of the output, at which state output is high. And because the output is high for all these possible combinations, so we need to consider all of this. Okay. So this is the simple justification. Okay. So let us try to design a logical gate of this one. How many logic gates will be required? Can anyone tell me to implement this priority encoder? How many logic gates are required?
4.
What are those logic gates?
So NOT gate, AND gate, and 2 OR gate.
2 OR gate, 1 AND gate, and 1 NOT gate. Absolutely correct. Okay, so let us try to see what those are. Here I have a 4 number of inputs: I0, I1, I2, and yeah, because I need one complement of I2 as well. Okay, so the complement of I2, and for that we need one inverter, and then I3. Okay, why we have made only the complement of I2? Because if you see these expressions, in this expression only the complement of I2 is required. Okay, so this is what the output is. Now you just simply, you can make the like B1 and B0. B1 is like simply if you're ORing I2 and I3, you will get B1. And if you are, so for this purpose, you need first the ending of I2 complement and I1. So I2 complement and I1 is ended, and then you need to OR it with the I3. Okay, so you need to OR it with the I3, and this is the circuit for priority encoder. Okay, so this is how we can make this one. So this is the B1 and this is the B0. Any doubt on this? If you have any doubt, you can ask the question, otherwise we can move ahead. Okay, so this is what the priority encoder is. So priority encoder basically depends on the input bit or higher order input bits, and even though there is change in the lower order input bit, it does not matter. Okay.
For all input 0, it acts like E equals to 0.
Yes, yes, it will be just like a disable one. Okay, it is not enabled. Okay, I just told you in the previous slide, it is same like the previous one. Okay. So yeah, so in that case, like even though all are 0, so the output will be 0 0 only, because it does not depend on any of these things. So even though, see, this is 0 0 0, so you can check it out, you will get 0 0 only. Okay, and if I0 is also 0, so you will get 0 only. Right. So yeah, one more thing, I need to tell you one more thing here. If I'm talking about this one, because this B1 and B0 is independent of this one. Okay, B1 and B0 is independent of the I0. So even though I0 is equal to 0 or it is 1, it will not affect at the output. So you can keep here instead of 1, you can keep it don't care. Okay, so if you are keeping it don't care, in the both the cases you will get 0 0 only. Okay, so you can make it don't care. I0 can be made don't care to get both the output 0. You got the point what I said? So this is important that you should understand. Okay, so these are few things that we should understand. Now, yeah, here are some tutorial questions for you. Just you have to design a octal to binary encoder, octal to binary priority encoder, decimal to BCD encoder and decimal to BCD priority encoder. So this is your homework. Please try to do it at home.